Today we are going to learn how to estimate the location of a square root that is a non-perfect square on the number line. You should be on page 10 in your notes packet. If we had the square root of 15 and we wanted to know where that was located on the number line, we know that 15 is not a perfect square, so we have to come up with a way to figure out where it would be. Well, we know from our work before that we can figure out an approximate location by thinking about the perfect squares that 15 would lie in between. Well, we know that this number is going to be somewhere between 3 and 4 on the number line. And this is because the square root of 9 is positive and negative 3, and the square root of 16 is positive and negative 4. So if I had a number line, and I had 2, 3, and 4, I know that 3 is the same as the square root of 9, and 4 is the same as the square root of 16. Since the square root of 15 is between the square root of 9 and the square root of 16, I know that it is located somewhere here. So if I were starting this number, I know that it would be 3 point something or 3 and something over something. But we need to figure out how we can get a better estimate than that. Now, another thing that we know about this is that the square root of 15 is going to be closer to 4 than it is to 3. We know that that's true because 15 is closer to 16 than it is to 9. So if I were putting this on a number line, I know it's probably somewhere here, but I still don't know what that number might be. So we need to come up with a method for figuring out exactly where would I place this on my number line. Well, since we know that the answer to this is somewhere between 3 and 4, we know that our whole number will be 3. So like we said, if we were writing it as a decimal, it would be 3 point something. If we were writing it as a fraction or a mixed number, it would be 3 and a number over another number. But we have to make a ratio to figure out the fraction or the decimal equivalent. What we're going to do here is start out with what we know, which is that this is between 3 and 4. So we're going to start out with our squares. We know that the square root of 9 is 3, and that's true because if I have 9 squares that make up a square, then it would have a side length of 3. We know that the square root of 16 is 4. Well, we know that this is true because if I have a square made up of 16 other squares, then each side length would be 4. So now we need to figure out what we would do next. The next step here is to think about where 15 would be located. So I'm going to fill in my number line from 9 to 16, and I know that I'm looking at 15, which is right here. The first question I'm going to ask myself is how far is it from 9 to 15? Well, 15 is 6 spaces away from 9. The next thing I'm going to ask myself is how far is it from my two perfect squares? So from 9 to 16. Well, I know that 16 is a total of 7 spaces away from 9. I can write this as a ratio by taking the distance of 15 from my first perfect square, so from 9 to 15, well, that is 6. And then my first perfect square to my second perfect square, so from 9 to 16. Well, that distance is 7. So I can write this as a ratio, and remember that this was between 3 and 4, so my whole number would be 3. So the square root of 15 would be somewhere on a number line close to 3 and 6, which I got from here, over 7, which I got from here. If I think about the square root of 48, I want to think about my perfect squares that 48 would lie in between. Well, I know that it's between 6 and 7 on a number line. So I know that it's somewhere between 6 and 7 on a number line. And I know that the square root of 36 is 6 and the square root of 49 is 7. Well, I know that the square root of 48 is somewhere in between there. So I know that it's located closer to 7 but because it's between 6 and 7, I know that it's going to be 6 and something, so we need to figure out what that fraction would be. The first thing we would do is figure out the distance from our first perfect square to the number that we're looking for. So from 36 to 48, that is 12 spaces away. So our numerator will be 12. Then we need to figure out the total distance from our two perfect squares to each other. So from 36 to 49, that is 13 spaces away. So the square root of 48 is located somewhere near 6 and 12/13. Now let's think about the square root of 52. If I think about my perfect squares, I know that 52 is going to be located between the square root of 49, which is 7, and the square root of 64, which is 8. Well, I know that 52 is closer to 49, so I know it's going to be somewhere near here. We just need to figure out what that number will be. We know that the whole number is 7 because it's between 7 and 8. To figure out what our fraction would be, we need to figure out our distance from our first perfect square to 52. Well, 49 to 52 is 3 units apart. And then we need to figure out the total distance from our two perfect squares. So the distance from 49 to 64 is going to be 15. Well, 7 and 3/15 can be simplified because 3 and 15 can both be divided by 3. So we would keep our whole number of 7. 3 divided by 3 is 1, and 15 divided by 3 is 5. So this is somewhere near 7 and 1/5. Now, it's important to remember that none of these are perfect answers to the square roots problems, because remember that if a number is in a square root symbol and it's not a perfect square, then this really is an irrational number. Well, if a number can be written as a fraction, which is what we're doing here, then this number is rational. So it's important to remember that this is not the exact location of the square root of 52, but this is actually just an estimate of approximately where it would be located. Now let's think about the square root of 88. So let's think about our perfect squares that 88 would lie in between. Well, I know that the square root of 88 is going to be between the square root of 81, which is 9, and the square root of 100, which is 10. I know that it's probably closer to 9, so I'll put it about here. So I know that if I'm writing this as a fraction, it's going to be 9 and now we just need to figure out the numerator and the denominator. Well, our numerator is the distance from 81 to 88, which is 7. And then our denominator is our distance from 81 to 100. Well, the distance from 81 to 100 is 19. So this would be approximately located around 9 and 7/19. For the square root of 180, we need to figure out those perfect squares as well. Well, when we think about 180, we know that it is in between 169. So the square root of 169 is 13. And it's in between 196, which is 14. Well, we know that 180 is probably a little bit closer to 169 than it is to 196. Oh, whoops. And now we just need to figure out where it would be located. Well, we know that our whole number here is going to be 13, and we just need to figure out our numerator and our denominator. Our numerator is our distance from 169 to 180, and that distance is 11. Our denominator is our distance from 169 to 196. Well, that distance is 27. So our solution is going to be approximately near 13 and 11/27 on a number line.